Right here, I will be proving the reduction formula using integration by parts. Now here, I will be taking one side of the equation, applying integration by parts, and after I do all the math and algebra, I should be able to obtain the right-hand side of the equation. So here, using the left-hand side of the equation, which is sine of x dx. Now, in order for me to apply the integration by parts, I am going to look at the right-hand side of the equation. Now, notice the first part of the right-hand side of the equation, it's supposed to be if I did u dv is equal to uv minus integral of v du. So the first part of the right-hand side of the equation is u times v. So this is going to give me a hint on what my u is going to be. So here I'm going to rewrite the function as the integral of sine n minus 1 x sine of x dx. Now the reason I wrote it this way, I know that these two functions are being multiplied together and they have the same base. So if I add the powers of these, which is this power is n minus 1 and this one has a power of 1, I would be able to obtain sine of n of x. So I didn't change the value of the equation, I just separated the sign in a unique way. So here I'm going to start by assigning my u to be sine of n minus 1 x. And then remember, my dv is everything that's left inside of the integral, which is sine of x dx. Now here, my dv, integrating it, it's not hard, it's straightforward. We know that the integral of sine of x is cosine of x. However, here the cosine is going to be negative because the derivative of cosine x is sine of x, negative sine of x. Since this is a positive sine of x, I need to multiply the v by negative. Now here, I need to do some work on my u to take the derivative. So I'm going to do some side work right here. So my u is equal to sine of n minus 1 x. I am going to rewrite this function as sine of x to the n minus 1. Now here I know that n is an integer, meaning n minus 1 is an integer. So I will be using the chain rule right here to obtain my du. So here I'm going to do the power rule for the outside function, n minus 1 times sine of x. Now n minus 1 gives you n minus 2 times the derivative of the inside function, which is cosine of x. Now here, I have my du. So my du is equal to n minus 1 sine of x. I'm going to rewrite this like this as n minus 2x times cosine of x. Now, putting what I have into the integration by parts, I would be able to obtain u times v. So sine of n minus 1 x times negative cosine of x minus the integral of v, negative cosine of x times du, n minus 1 sine of n minus 2x times cosine of x dx. Now right here, I am just going to rewrite this equation as negative cosine of x times sine of n minus 1x. Now remember, n minus 1 right here is an integer. So in an integral, any constant I can pull out. So I will be pulling out the negative and the n minus 1, and I will obtain plus n minus 1, the integral. Now I can reduce this by combining like terms. So I can multiply cosine of x and cosine of x, and I will obtain cosine squared of x times sine of n minus 2 x dx. So now here I'm not trying to evaluate the integral. However, I need to obtain only the integral to be sine of n minus 2. Remember, the right-hand side of the equation gives you a hint on what the equation is going to be. So how will I obtain that? So right here, I know that one of my identities, my trig identities, is the Pythagorean identity, which says that cosine squared of x plus sine squared of x is equal to 1. Manipulating this equation gives me cosine squared of x is equal to 1 minus sine squared of x. So right here, I am gonna replace cosine squared of x with 1 minus sine squared of x. So that gives me cosine of x sine n minus 1x plus n minus 1, the integral. Now in the place of cosine of squared of x, I'm gonna write 1 minus sine squared of x times sine of n minus 2x dx. So now right here, I am just gonna use some algebra tricks to rewrite this. So negative cosine of x times sine of n minus 1x plus n minus 1, the integral, I'm gonna distribute it, the sine, n minus 2 inside, so that's gonna give you sine of n minus 2x minus sine squared of x sine n minus 2x dx. So now right here, two functions being multiplied that have the same base, I can just add the powers and I would obtain negative cosine of x sine of n minus 1x plus n minus 1 integral of sine n minus 2x minus sine of nx dx. Now, whenever I have an integral and two things are being added or subtracted, I can separate the integral. So right here, I will have negative cosine of x sine of n minus 1x plus n minus 1, the integral of sine n minus 2x minus n minus 1, the integral of sine nx dx. So right here, I'm just going to rewrite the function I started with, which is sine of nx dx is equal to negative cosine of x sine of n minus 1x plus n minus 1 integral of sine n minus 2x minus n minus 1 integral of sine nx dx. Now right here, notice that this integral right here is the same as this integral right here. So I can move that integral to the other side of the equation. Since this is being subtracted, I can just add n minus 1 of sine nx dx to the other side. So right here, I have a 1. Since these are the same, I can just add the numbers in the front, which is n minus 1 plus 1. So that gives me n integral of sine n of x dx equals negative cosine of x sine n minus 1x plus n minus 1 integral of sine n minus 2x dx. So now the only thing that's left to do is just get rid of this n, and I would be able to obtain the right-hand side of the equation. So by dividing n to both sides, I would obtain sine of nx dx equal to negative cosine of x sine of n minus 1x plus n minus 1 sine of n minus 2x dx all over n. this could be rewritten as the integral of sine nx dx negative 1 over n cosine of x sine of n minus 1 x plus n minus 1 over n integral of sine n minus 2x dx, and I obtained the right hand side of the equation.